Assalamu alaikum and welcome to this video. In this lesson, we'll talk about the box plots, which are a very important tool for a quick summary of the variability in the data set. These plots are also known as box and whiskers plots because of their resemblance with the cat whiskers, and we are going to see how. Box plots provide a quick visual summary of the variability of values in data set as they present a five-pointer summary, including these five values, which are minimum, the Q1, median, Q3, and max. Now, up till now, we have seen, out of these five values, we've seen minimum, median, and max. And we have yet to talk about what Q1 and Q3 are, which we are going to do in this video. So this is a simple box plot. And here we can see these quantities represented. This bar here represents minimum, and this is a line from the border of this box to this line here is whisker, one whisker, and the other one is here from the other border of this box to the maximum value. So because of this, they're known as the box and the whiskers plots. And inside the box, we have the left border is lower quartile or Q1, which we will see what it is. Then it is median, which we know. It is also known as Q2. And then the upper or quartile 3, which is the right border of this box. The span between the lower quartile and upper quartile is known as the interquartile range. The box plots also model the outliers or the extreme values in the data. Here we can see a more packed box plot, which has all of those five quantities which we mentioned with Q1, Q3, median, IQR, and minimum maximum. In addition to that, we see that there are these two dots here to the left of this bar of the minimum value and to the right of this bar that represented the maximum value. These dots are basically the outlying points of your data set. और ये expressions हैं जिनके through हम calculate कर सकते हैं कि कौन सी values data set में outliers हैं. So these are the lower outliers and these are the upper outliers. यानी कि जो higher side के ऊपर outliers हैं, they are also modeled, and lower side पे जो outliers हैं, they are also modeled here. And we also see that Q1 is called the 25th percentile, and Q3 is also written as 75th percentile. And so we are going to see in a while what this means. So box plots are majorly based on the quartiles values, and there are three quartile values, Q1, Q2, and Q3, of which Q2 we already know, which is median. And the idea of quartiles is that they split a data set into four parts with equal number of observations in each part. Just as in case of median, जहाँ हमने बात की थी कि it is one value which splits the data set into two equal halves in terms of the number of values lower and higher than this value. तो इसी तरीके से क्वार्टाइल्स पूरे डेटा सेट को चार हिस्सों में डिवाइड करते हैं इक्वल हिस्से in terms of number of values in each of the quartiles. अच्छा जी, अब ये इस तरीके से है. The first quartile or Q1 to the left of it, यानी कि उससे नीचे, this is going to be a value जिससे नीचे 25% of the data exists. ठीक है? Then median or quartile 2 is what we know. Below that, there is 50% of the data, and other 50% is above this value. फिर Q3 आ जाता है, जिसका मतलब ये है कि ये एक ऐसी वैल्यू है कि there is 75% of the data which is lying below this value and only 25% of the data which is above this. ठीक है? तो फॉर एग्जाम्पल अगर मेरे पास जो वैल्यूज आई हैं इसमें 10 आया Q1 के लिए, तो इसका मतलब है कि 10 से नीचे मेरे डेटा सेट में जितनी वैल्यूज हैं वो कोई भी वैल्यूज हैं, दोज मेकअप 25% ऑफ द डेटा. और 10 से ऊपर जो वैल्यूज हैं दे मेकअप 75% ऑफ द डेटा. और आपने देखा होगा कि जो टेस्ट होते हैं नेशनल टेस्टिंग सर्विस के एनटीएस के, उनमें क्वार्टाइल्स और परसेंटाइल्स बेसिकली रिपोर्टेड होते हैं. ठीक है? जैसे कि इन एडिशन टू एब्सोल्यूट मार्क्स, परसेंटाइल्स रिपोर्ट किए जाते हैं। अब परसेंटाइल का कॉन्सेप्ट बिल्कुल ऐसे ही आप समझ सकते हैं जैसे क्वार्टाइल्स हैं। द ओनली डिफरेंस इज दैट percentile, as the name suggests, they break the data, they divide the data into 100 equal parts in terms of the number of values. तो फॉर एग्जाम्पल अगर ये कहा आपको पता चले कि यू आर एट द 87th percentile, दिस मीन्स कि देर इज 87% ऑफ द डेटा which lies below the marks that you got. ठीक है, तो एब्सोल्यूट वैल्यूज की रिप्रेजेंटेशन की बजाय जो परसेंटाइल्स है ना एंड क्वार्टाइल्स, दे आर बेटर रिप्रेजेंटेशन ऑफ the rank of some value in the data set. Rank in terms के अब आप अगर 87 परसेंटाइल है ना, तो दैट मीन्स के 87 लोग, अगर टेस्ट की बात करें तो 87% लोगों ने बुरा फॉर्म किया आपसे, इफ यू गॉट 87% मार्क्स, और 13% लोगों ने बेहतर परफॉर्म किया। ठीक है, अब दिस बेसिकली व्हाट इट डज इज इट एक्चुअली बिल्कुल इसी तरीके से जो परसेंटाइल्स हैं उनका कॉन्सेप्ट भी समझा जा सकता है। तो जो परसेंटाइल्स हैं वो पूरे डेटा को 100 इक्वल हिस्सों में डिवाइड करते हैं, और उसका मतलब ये होता है कि फॉर एग्जांपल इफ समवन is at a value is 87th percentile, it basically means that 87% of the data lies below this value, and only 13% of the data lies above this value. और आपने देखा होगा कि नेशनल टेस्टिंग सर्विस के जो, अगर आपने ऐसे कोई टेस्ट दिए तो उसमें जो रिजल्ट्स होते हैं, in addition to the absolute marks, to the percentage value, the quantiles, well, the percentiles values are also reported. और उसकी रीजन ये होती है कि percentiles they give a better representation of the ranks of marks in terms of relative performance. And now we're going to see how we can calculate these values. Q1 means that 25% of the data below it, 75% of the values in the data set are below Q3, and Q2 is same as the median, below which 50% of the values they exist. So Q2 is basically the median. To find the quartile values, this is the expression that we use. And you can see that it is very similar to what we did for median, except for we have this K here and we have a 4 here. And what this gives us is the position of the kth value, right? K here is whichever quartile you want to find out. K Q1 के केस में K1 हो जाएगा, इधर भी 1 आ जाएगा, 2 के केस में 2 हो जाएगा. And when we replace K by 2, Q2 is median, we know, and here it will become, we have a 2 here, we have a 4 here, these cancel out, and we are left with n plus 1 divided by 2, which is exactly the expression to calculate the median position. So this gives us the position. Again, I emphasize it. जब आप data को organize कर लेंगे, because now we are talking about positions, so the data needs to be sorted. So when we arrange the data in a ascending or descending order, in case, of course, we need to do that in ascending order because Q2 and Q3 की positions जो हैं वो fixed होंगी अब, तो हम ascending order के अंदर data को arrange कर लेंगे. Now, when we calculate this value, where n is the number of items in your data set, this is the size of your data set, this is going to give us the position where your quartile value lies. And then you will go back to the data set and find out which value is there at this position. वो value आपको quartile की value देगी. ठीक है, if the position comes out to be fractional, जैसे median में भी हुआ था, so we are going to take the average of this and the next value in the data set. For simple computations, again, if you just want to have a very simple understanding of what these values are and how they can be calculated, it is Q1 is the median of the lower half of the arranged data, and Q3 is the median of the upper half of the data. So, for example, if we have some values in the data set, say if we had 11 values, So we are going to find the sixth value, above which are going to be five values and below which are going to be five values. Now we're going to consider, ये तो आपको median आ गई ना, Q2 आ गया. Now if we consider those halves separated by the median as two different data sets, so then you're going to pick up for the first half, जो कि आपकी lower values आई थी, median से left वाला half आया था, उसके अंदर से you are going to pick up the third value which will be Q1, क्योंकि वो मीडियन आ जाएगा लोअर हाफ का, और इसी तरीके से अपर हाफ का मीडियन जो आएगा दैट विल बी Q3. बट वी नीड टू हैव अ स्टैंडर्ड वे टू डू दिस फॉर एनी काइंड ऑफ डेटा सेट जिसमें कोई भी नंबर ऑफ वैल्यूज है, इवन हो या ऑड हो. तो वो जो नीचे एग्जांपल यहाँ पे गिवन है, दिस इज बेसिकली इट corresponds with this one. We have these values, which are number of admissions applications for BSCS program in any university received in 14 consecutive days. So these are 14 values here, jitne applications आई थी. Or the first thing we need to do is to sort this, and we get this. Okay, so from this sorted data, we can quickly identify that 15 is the minimum value and 97 is the highest. For Q1, we use this expression. So 1 is substituted for K, and we get 14 plus 1 divided by 4, which comes out to be 3.75th position. Now, fractional value, this means that 3.75th, to calculate the quartile value here, we'll have to take the average of two values, which are the third and the fourth one, because this is the third value and 0.75 needs the next value also. For Q, so the Q1 now comes out to be, here we find the third and fourth value, 1, 2, 3, and 4. So 26 plus 26 by 2 is 26. So Q1 is 26 here. और Q2 के केस में we replace K by 2. तो यहाँ पर आ जाएगा, जब ये सारी calculation की, we got 7.5th position, which means that we'll have to take 7 and 8th position. So this was 4, 5, 6, 7, and 8. So we are going to have 48 and 63 here. उनकी average निकाली तो 55.5 is Q2. And for Q3, this is the position, which is 11.25th, which means 11th and the 12th position. So here we had this 8th, 9th, 10th, 11th, and 12th position. It's going to be the average of 83 and 87, and we get 85. So this is how we can calculate Q1, 2, and 3. Now, the another quantity that was plotted, that was represented on the box plot, this is actually not included in the 5-pointer summary, but it's something which is derived from those values. 5-pointer summary में सिर्फ min, Q1, Q2, Q3 और max आता है. लेकिन Q1 और Q3 को इस्तेमाल करके we can calculate the interquartile rate, which is the difference between Q3 and Q1, and it is one measure of dispersion also. ठीक है, ये बेसिकली क्या मेजर है कि आपको बताता है कि आपके डेटा सेट के अंदर जो सेंट्रल डेटा है ना, 50% डेटा, हाउ इज दैट डिस्ट्रीब्यूटेड. ठीक है, जो सेंट्रल 50% डेटा है, क्योंकि देखिए Q1 से नीचे 25% डेटा है, Q3 से ऊपर 25% डेटा है, तो ये दरमियान में जो 50% डेटा है ना, हाउ मच इज दैट डिस्पर्स्ड, तो ये उसकी रेंज बताता है. ठीक है, उससे देयर आर मेनी other analysis where we use the IQR, and one of those is the calculation of outliers. अभी हम देखेंगे उसको. So the span of the box in the plot measures the IQR from here to here. अच्छा जी, the same example, but now here we have 15 entries. I think we have 14 entries. It's a typo here. It is the same data. We have 14 entries here, and the data is already sorted. So we got, yes, it's the same data, and we got the same values. Now, IQR is the difference between Q3 and Q1. We had Q3 as 85 and Q1 as 26. So the difference comes out to be 59. These were the markings for Q1, Q2, and Q3. Now we're going to use the IQR to find out the outliers in our data set. The whiskers of the plot go up and down to the max and minimum values that we know. ठीक है, लेकिन और मैक्स एंड मिनिमम तो आपको फॉरन से डेटा सेट देख के पता चल जाए, लेकिन इन एडिशन टू दैट ये जो whiskers आ रहे हैं, there are upper and lower fences which are not plotted, which are not explicitly modeled on the data set, on the box plot, but they are there. और वो fences क्या होते हैं? Anything beyond those fences is considered an outlier. Upper fence is the value above which any data entry is considered an upper or a higher outlier, and similarly, the lower outliers which are below the lower fence. To calculate upper fence, we have this expression that we saw in one of the earlier slides also. This is Q3 plus 1.5 times the IQR. So now we know how to calculate the interquartile range. उसको multiply करेंगे 1.5 से और Q3 में आप add करेंगे तो you'll get a value here somewhere. इस जो अपर विस्कर है ना, उसके बियॉन्ड यहाँ पे कहीं पे वो वैल्यू आएगी, एंड दैट वैल्यू explicitly यहाँ पे मॉडल नहीं होगी, but that will be an upper fence. Any data value in your data set which is above this value will be considered an outlier. ठीक है, इसी तरह से लोअर में क्या है? लोअर वैल्यू इज गोइंग टू बी Q1 जो फर्स्ट अप लोअर क्वार्टाइल है माइनस 1.5 टाइम्स द IQR. ठीक है, तो आपने 1.5 टाइम्स IQR एक दफा कैलकुलेट करना है, Q3 में ऐड करना है अपर फेंस के लिए, Q1 से सब्ट्रैक्ट करना है लोअर फेंस के लिए. तो सिमिलरली beyond this whisker we are going to get the fence value here. Anything, if there is anything below that value in your data set, that will be an outlier. ठीक है, अच्छा अब यहाँ पे देखिए मिनिमम और मैक्सिमम आगे 15 और 97, वो तो आप सॉर्टेड डेटा से बड़े आराम से उठा सकते हैं बिकॉज दोज आर गोइंग टू बी दी स्टार्टिंग वैल्यू एंड द एंडिंग. ये यहाँ में मॉडल हो जाएंगे whiskers. Upper fence क्या आएगा? 85 which was the upper quartile Q3 plus 1.5 times this uh, the interquartile range, and interquartile range we calculated in the last slide which was 59. तो ये वैल्यू आ जाती है 173.5. अगर डेटा सेट को देखें तो we can see that there is no value above this value, so there are no upper outliers in our data. For the lower fence, we subtract this 1.5 times IQR from 26, which is the lower quartile. आया था ना Q1 26. So we subtract करें तो we get this value minus 62.5. And here we can see that we do not have any value which is lower than this. ठीक है, तो इस वजह से इस डेटा सेट में lower outliers भी कोई नहीं. Okay, this is the how now we are going to plot it. Now this is the data set, and this time we've done it vertically. So you can do it vertically or horizontally, whichever orientation you need. अच्छा, ये सारी मॉडल्ड है जो 5 पॉइंटर समरी है. वी हैव मिनिमम. अच्छा, यू कैन हैव इट डॉट हेयर और बार, वट एवर वे, दोनों तरह की विजुअलाइजेशन इस्तेमाल होती है. ठीक है, लेकिन ये जो लाइन कनेक्ट करेगी ना, ये मिनिमम को करेगी, एंड दिस मिनिमम इज बाय द वे the one which is within the range of the regular data. यानी outliers को निकाल के जो minimum value है, that is the minimum of your data set. तो 15 हमारे केस में outliers थे ही नहीं, so this is the lower whisker. ये अब this is not the lower boundary, lower fence. This is the minimum value other than the outliers. 15, the lower quartile 26, the upper quartile the upper quartile 85, the median or quartile 255.5. And where we have this median, we put a bar inside the box. एक line आ जाती है. इसके और फायदे भी हैं, अभी हम आगे देखेंगे. And this is the highest value, which is 97. Since we do not have any outliers, so we don't see dots beyond the whiskers. And this is IQR. Let's have a look at another worked example, which is this data. And these are 21 values. And this data is already sorted. So we can see that we have 7 as the lowest value in this data at this point. And 100 is the highest value at this point. And we need to see whether there are any outliers or not. Q1 is the comes out to be 5.5th position. वही वाला expression है 21, which is the data set size plus 1 divided by 4 into the quartile number. So we get 5.5th position, which is 1, 2, 3, 4, and 5. So 5 and 6th. Why? Because this is a fraction value. So that's the average of that is 40.5. Q1 is 40.5, Q2 is 11th position. The expression यहाँ पे आप 2 change कर दे तो you'll get 11th position, and 11th position is 50. Then we have Q3, which is 16.5th position, and that is the average of 57 and 63. Here 57 and 63, and we get the value to be 60. Now we calculate the IQR. IQR is Q3 minus Q1, 60 minus 40.5, which is 19.5. And then the calculation of upper fence by this expression, this comes out to be 89.25. And when we look at the data set, we have two values which are above this upper fence. So any value which are above the upper fence is considered an outlier, upper outlier. So we have two outliers on the upper side. For the lower fence, we have Q1 minus 1.5 times IQR, and this is 11.25. अब data set में देखें तो we have one value which is below 11.25, and that is 7. So this is the lower outlier. Minimum value. Now, these are the outliers, 7 and 90 and 100. So the remaining values are to be considered for minimum and maximum. So now a regular data point, 7 is not a regular data point anymore because that's an outlier. तो अब हमारे पास 15 आएगा minimum और maximum आएगा 84 because these two are the outliers. तो अब जब मॉडल करेंगे तो ये बॉक्स प्लॉट आपके पास आ जाएगा. ये बॉक्स प्लॉट एक्सेल में बना हुआ है. आप सिंपल अपना ये डेटा सेट वैसे भी एक्सेल में डाल देंगे और बॉक्स प्लॉट क्रिएट करेंगे तो इट इज गोइंग टू गिव यू दिस. ठीक है, वो कैलकुलेशंस ऑटोमेटिक भी हो जाएंगी, बट वी मस्ट नो हाउ दोस आर कैलकुलेटेड. अच्छा, इसमें ये आ गया 15. ये आउटलायर as a dot modeled here, 40.5 lower quartile, 50 as your median or Q2, and 60 as the upper quartile या फिर Q3, 84 जो कि highest value है, highest regular value, and two outliers 90 and 100. So this is as simple as this. Now we can use box plots to get an idea of the skew of data as well. If we have a box plot of this shape where the median or the Q2 is close to the Q3, ये क्या बताता है? When Q2 is close to the Q3, it shows that Q1 जो है ना वो काफी दूर है. ठीक है, मीडियन से भी दूर है और Q3 से भी दूर है. तो दिस एक्चुअली शोज, अगर हम इसको प्लॉट करते हैं डिस्ट्रीब्यूशन प्लॉट में, तो ये आपको बता रहा है कि इसकी लेफ्ट टेल काफी लंबी है. ठीक है, सो दिस इज नेगेटिव स्क्यू या फिर लेफ्ट स्क्यू. और वी नो दैट इन केस ऑफ लेफ्ट स्क्यू जो मीन है ना, दैट इज pulled towards the left by the extreme lower values. यानी इसका मतलब ये है कि यहाँ पे कुछ outlying values होंगी जो कि लोअर साइड के ऊपर है, तो दे आर पुलिंग द मीन टुवर्ड्स द लेफ्ट, व्हिच मींस कि मीडियन इस केस में बड़ा होगा फ्रॉम द मीन. ठीक है, इसी तरीके से ये सिमेट्रिक होगा, तो आपका जो ये मीडियन की बाहर है ये बिल्कुल सेंटर में आएगी डेटा के. तो दा मतलब ये होगा कि आपका मीन और मीडियन और एंड मोड कोइंसाइड कर रहे हो. ठीक है, तो इस केस में जब ये जो सिमेट्रिक है, देयर इज नो स्क्यू, तो द मीडियन बार इज गोइंग टू बी एग्जैक्टली इन द सेंटर ऑफ दिस बॉक्स. और इसका मतलब ये है कि जितना स्पैन है ना अपर क्वार्टाइल का, उतना ही लोअर क्वार्टाइल का स्पैन. सो द रेंज बिटवीन Q2 and Q1 is the same as what is between Q2 and Q3. अच्छा, और इस किस्म का अगर आप बॉक्स प्लॉट होगा तो दैट विल बी राइट स्क्यू, which shows that the right tail will be longer, and in this case the mean will actually be pulled towards the right by extreme values on the right. तो जो mean होगा that will be greater in magnitude to the median in case of right skew. Okay, there's an example where the box plots have already been constructed for the temperatures at these 5 different locations. Okay, जो Timbuktu, Havana, Sydney, Santiago, and whatever this is. अच्छा, अब ये क्या बताते हैं? This, by the way, you can expect questions like these in exam. और वो क्या आप इसमें से क्या निकाल सकते हैं, क्या assess कर सकते हैं? This shows that at a very quick glance we know that this location is having the highest temperatures. ठीक है, because इसका डेटा रेंज is on the higher scale as compared to the other temperatures. Then we can see that there are outliers in case of Havana, and there are outliers, the lower outliers. And sometimes the data goes below, the temperature actually goes below on the lower side to very extreme values. Or here we have outliers on the upper side. So this means at this location, sometimes the temperatures, they go to extreme values on the upper side. बहुत ज़्यादा बढ़ जाता है. And then there are outliers and quite lower outliers for this location. And we can see that it is actually towards the negative side. So sometimes the temperatures, they actually go below the freezing point. बहुत ज़्यादा. And we have outliers here also. Again, the last location. Acha. We can see that this location has very small range from here IQR also, and from between the minimum and maximum, this is very small. So the temperature, they vary between a small range, but we have larger ranges here, and you can also see that this is quite symmetric. So the temperatures, they are distributed quite symmetrically. Here it is also symmetric. यहाँ पे थोड़ा सा हमारे पास आ रहा है right skew. इधर भी symmetric है, और this is almost symmetric. But here again we have a little right skew क्योंकि ये जो median है ये थोड़ी सी नीचे lower side पे नजर आ रही है Q1 के side पे. So there are many other kinds of observations that can be drawn from this representation, and I leave it as an exercise to you.